Good morning, everyone. Welcome to the webinar, which is called How to Start with Precision Farming. Thank you very much for joining us. My name is Pavel Hayek, and I will be the host of yours for today's webinar. This webinar is organized as a part of the ongoing AgriHub Inspire Hackathon 2022. And particularly, this webinar is a part of the challenge number 16, which is analysis, processing, and standardization of data from agriculture machinery for easier utilization by farmers. Before we start, some technical information I will give to you. This webinar is being recorded, and the recording will be available on the YouTube of the Plan for All Association and will be sent to the registered persons via email as well. If you have any question to our speaker, you can either use the chat box of the Zoom meeting room, or you can speak up after the presentation of our speaker. I was talking about the speaker, and let me introduce him. It's Mr. Pavel Knip from the AGCO company, who will present the first steps that are needed to be taken to implement precision agriculture on the farm. So that's all from me for now. Thank you once again for being with us or seeing us afterwards. And Pavel, the floor is yours, and you can start with your presentation.
Good morning, everybody. Thank you very much for entrance this presentation. Today, I would like to share with you a couple information about how to start with precision farming. Just a few words about my background. I'm involved to precision farming since 1997, when I started in Czech Republic, a private company, as a specialist for advisory for data collection from the field and creating variable rate application maps for farmers who at that time started with precision farming, and also for field services, machinery services, who did for farmers these applications. During these 25 years, I had also experience about how to run the farm, and I had a chance to be a head manager of crop production on farm with 6,000 hectares. And during this experience, I saw how important and how it's extremely complicated to implement or adopt the tools of precision farming on the farm, just as a farmer. And what is really advice if the farmer asks for help, advisory company or a specialist who can support this adoption of precision farming tools on the farm. So right now I'm also working as advisor and supporter, technical supporter for precision farming tools and company AGCO. And today I would like to go around how to start, and I would like to explain and summarization of my experience and a colleague's experience in AGCO, how to start the precision farming, precision agriculture on the farm, and what is a very important to do on the beginning, and how to continue step by step for the next adoption, and to achieve a better aim. So precision farming in crop production, it's something undeniable. What we have benefits of precision farming practices and technologies in the terms of yield saving. And with the help of satellite navigation technology and information technology and geographic system, information system, which must be adopted on the farm, we can collect and analyze information from the soil crop and also the weather, which is also important factor, and optimize individual steps and application as much as possible. So this is actually the base of precision farming tools to be on the right place, right time, with right rate for the crops. I put it on the 4 steps of adoption of the precision farming agriculture in the farm. And these 4 steps are not like you have to collect and finalize first step, then you have to go to the second step, then you have a third step, and then you continue with the evolution and next development. Generally, very good. It's to fill up the first step, and actually during the first step, also looking forward to second and the next other steps, just to have more information and be informed as a farmer on the farm, what is a new and what is a practically saved and what is practically done on the farm already in the country or in worldwide. Furthermore, we have to say that not everything, not every practices in precision farming, which are used in the North America market of farmers or West European countries or other countries, Australia and so on, doesn't have to fit up for other countries. So it's always good to know about the technology which is coming and technology which is using and practically done on the farm, but still looking and tested exactly fit for the particular farm in different countries with the particular crops which are historically growing in the field in the country. So it's important to just fit technology on the farm. It doesn't matter maybe what neighbor is testing, but important is for this fit exactly on the farm the farmers is running. But go back to the first steps. What is very important to start with the precision farming, and I can fully recommend to start with the guidance. Guidance is one of the basic tool which we have to equip the tractor to start with the precision farming. And the second step to start it with another step when we have to plan it, how to fit and how to best fit the lines and the trim lines we want to use it during a crop production growing. So these 2 steps, we have to fill up the first. And what we want to achieve is to reduce the overlap, increase the comfort of the driver, and start to generate data, which are very important for the precision farming and each farm. And the second step, we should get a good practice. So good practice with the guidance, which must be trained and many times just done the practice. Set it and play with the field boundary and find the optimal way and trim lines for each field. And even more, adopt the first or one of the first technology as is a section control via the isobus. So, and the first time we start to see the input saving, the first input saving when we can achieve, when we start use it a guidance and section control and CTF on the farm, CTF light on the farm. So it's something what we want to set it and find the best practices for saving and reduce the overlap on the each field with each crop. So it's mean we have to take care more about how to drive on the field, what is the good size of the implement we use on the field, what is a good size of power of the tractor, and so on and so on. So that every farmer who wants to start with precision farming, he should start with the two main points would be what he has to do on the farm. So first, looking for a good and fit guidance for his machinery, or looking for new tractors. And the second thing, start to generate the database of the field boundaries and trim lines created optimal way for each field and for the each crop he grow on the field in crop rotation. So these two steps are very important, and it must be done as a first thing to start for the next development. Also, these first two steps are already set for saving the inputs and as I said, the others what the farmers expected in the crop production. The third point is advance. So it's mean to just develop and increase the technology of adoption of the technology on the farm. So first of all, to make the best guidance on the tractors he used and connect it to implements he used in the crop production with the best functions we can use it. So for example, today is available a good function as isobus, so we can edit all these technology between the in the tractor implement and be equipped on the farm. Important is documentation. So as we start on the first step with the data collection, we have to create a good documentation place in via the information technology. So library for the farm with field boundaries and all these trim lines and bay lines created for the particular field must be saved and evenly check it and actualize it with the active the situation on the farm. The next thing would be added as a yield mapping or yield scanning. We are using the harvester machines and yield monitors, or we are using the big data from satellite imagery. And the last step, which should be an advanced step, is prescription maps, which are coming from all these data collections we create on the farm, and we can calculate another saving and optimal support of crop production and crops on the field. So when we start to use a data collection, when we start and continue in the input saving, when we have from the previous step reduced overlap and also the increased comfort and a new data generation and inventory, it's the important step which must be done fluently with every step, every entrance to the field, with every support. So this is the third one and the most important step when we get it to the level of the precision farming adoption on the farm. But if we are adopted all technology, we are still cannot stop, and we need to continue with the next development and evolution. And this is about the fourth step, when we actually run third and fourth step together, and we try to always adopt the best solution, the best technology on the farm, and just still keeping the training and new knowledge for the farms and pushing the whole system of precision farming adoption forward. Just what we like to do with these steps, we want to increase sustainability of the soil production and reduce maximally a bad environmental impact, because this is exactly where we want to continue in the future and what we want to have for the crop production and feeding of human on the world. Let's go to the next page. I prepared just briefly agenda, how to simplify the table what I had on the previous slide, and just go step by step. What should farmer should do and the first steps, and then just continue to the better technology or implementation of better technology on the machinery. So in a tractor and also in the implements. So let's take guidance first and mapping, which is very important. Let's go to the control traffic plan, which is the optimization of the tramlines on each field. Let's talk a little bit about the management zones. Let's have a look on the soil sampling, next technology adoption. Then we will very briefly go through the documentation, and what is very important almost on each farm is on-farm research, when the farmer should follow results from his farms and from his research. His own research could be supported by other people, advisors, and so on. But this is the important when the farmer in his farm is doing something to get the result from his steps and his decisions on the crop management. So just very briefly on the guidance mapping. Guidance on the tractor is actually the most important thing what we can have it, and accuracy of the antenna and the work could be a different. Generally, we divide it to the three levels when we have a sub-meter accuracy, decimeter accuracy, and centimeter accuracy. We recommend that every mapping, what we do with the tractor or implement, it must be done by the RTK, so that the most high accuracy, centimeter accuracy level only, because this is what we can repeat and what we can use it on the next year's next work on the field, and this is what is must be stable and perfect. So what we are looking for the mapping, it's boundaries of each field or each part of the field. We want to divide it for some reason or for some years. Then we want to map all obstacles like waterways, low weed areas, protected areas, green areas, or tile-in outlets, wells, hydrants, or power pool, what is possible to see on the field, not on each field, but it's possible on some field. And it doesn't have to be on the particular farm, but it's very often to see it at least on the couple fields of each farm. So then when we have everything together done, it can take some more time, maybe 1 year or more, or just one season. It's depend on the farmer how quick he want to start and make a detailed map of the plan. What is very important is to keep the field yearly maintenance if it's necessary. So it's important that the field boundary are not corrupt by the tree, shrubs, or some others obstacles. So it's important to have it. in a good shape. And what is very important for database is actualization of the farm database at least 2 times per year. It's very special for the Czech market that we do actualization of field boundaries 2 times a year, just because we have a many exchange and changes in the field boundaries and the numbers of the fields almost on each farm. So this database of the field boundary, all these obstacles are very, very based for next precision farming adoption on the farm, and farmer can decide it very easy what he's doing and where he's doing what. So next, what is coming as a system, we call it a controlled traffic plan, which generally could be a very sophisticated system on the farm, but it's depend on how many crops we have on the farm in crop rotation, and it's depend how the farm is able, of course, and how farm is able to make a changes of all machine which is required, and many changes on each machine, and actually is a need to be homogeneous, the system of tractors and tires and implements with which must be very well managed. So generally, controlled traffic functions are very sophisticated systems, and I wouldn't recommend to start with this from the very beginning, but I would recommend take like a light version of this system and start to really organize to buy a new machines and organize the old machines together to get the best result, how to get the optimal trim lines for each crop and each field. So it's really important, and to do this, it's very important to have the database with all field boundaries, and we can start to calculate and possibility how to make it. So if the farmer used the system together with advisor or his own, just to go field by field and check it, what is the optimal way and how to set the optimal way with the optimal width of each field. It takes a longer time, but it's really a gate to the precision farming and the best start how to continue with the adoption of the precision farming technology on the farm. From my point of view, I think it wasn't too much announced it on the beginning or previous years. If we take it 10 or 20 years before, we didn't have a very accurate signal, a correction signal for all machines, and machine could drive on the field, let's say on the sub-meter accuracy, and this measuring of the turn lines was changed every year because of the moving of satellites and offsets and so on and so on. But today we have a big advance to create a perfect database for each farm with a field boundary and trim lines, and this is exactly the base how to start with the precision farming and how to start to collect the correct data for the future and daily management on the farm. Just a very short example, which was created by my friend, my colleague, and he took a field on the one farm, which is not even, it's not with the field with the 4 angles, and just the field, which is very different and heterogeneous. And he just set it with the 6-meter width implement, the possibility of trim lines on the field. And he just get a very simple and clear result. If you take actually the second picture on the right, and you take a traditional way, how was the farmer used to do the operation on the field, and he calculate something different, and he tried to optimize the way lines with the same width 6 meter. He just get a very simple result and clear result. So he get a possibility of the field work of time reduced by 37 minutes for this 6 meter width, and he also increased productivity by 1 hour, about 0.3 hectares. So it's very easy to get this result by calculation. What is the best way, and use the trim lines for the crop he's growing on the farm. The farmer is growing on the farm. So this is the very simple example why to start check it every field and how to get the best result for the every field on the farm. Another thing what is very important in this is how to set the trim lines and how to start to using a correct or more efficient machinery and on the farm. So tradition is very simple. What the father was doing on the field, usually son continue with this, but both father and son, they had a different conditions and different possibilities and solutions on the field. So today the farmer is able to calculate and what is the better and what is not. And we know very well that we can use the trucks or wheels machines, and what could be a difference between, we can see on the very short example. So the tire track coverage are reduced by 14%. And if we take the differences of the crop yield between the truck actually on the trim lines and on the not touched field by wheel, it could be between 2.5 and almost 12%. It depends on the crop and the sensitivity of the root system of each crop. So, for example, we have a winter wheat where it could be 2.5% of saving. We have a spring barley, about 10%, and we can take a oilseed rape, which is also very popular in Czech Republic, and could be even almost 12%, because the crop oilseed rape is very sensitive, and it has a possibility, if it's not pressed soil, it can create a very nice root and support a yield as much as possible. So the difference is for sure. Here was a short explanation that they can save from 5 to 20 euro on the hectare on the farm level, when the farmer reduced the soil compaction by not driving just on the field like it's necessary, but calculation. So the third place takes the management zones, and farmers should start thinking about the management zone and try to get the possibility how to map the field and how to create the different zones he wants to use it on the future. So once he have created just the plan for trim lines, way lines, optimal way lines on the field, then he can start to create a management zone and monitor what's he can do it under his particular conditions. So based on the optimized way lines, establish a management zone along the trim lines. He can use the satellite imagery, some NDVI sensors, place it on the tractor, and then he can use some tractor data created during the soil preparation on the spring or on the fall, some elevation based. So it means the 3G terrain or from the some task he create on the field when he used the guidance and satellite corrections. Then he can optimize the bay lines and synchronize with the sprayer tracks which could be the most biggest implement he used on the farm, and then he can divide it to the particular. In this case, each 30-meter sprayer tract can be individual management zone. So divide it into the soil sampling grid zones and use the soil sampling grid matching the trim line for in the system of optimization of these trim lines and way lines. Important is that the grid sampling is used when there is no data available for zone sampling and based on the yield on soil. Of course, from the beginning, the farmer has less information on the heat system, so he can decide if for some even sampling later on when he start to use the management zone, and he activate these zones for all or as much as possible works and application on the field. He can use these management zones also for sampling, just for the case to save another money for samples processing and next using. So always it's possible to decrease the cost for any operation we can have available or we want to do on the field. Examples just about the 3G. Today's satellite navigation can help the farmers better monitor the elevation and create a 3G picture for each field, even for whole farm. So if the farmer puts together all monitored field for the 3G, he can very easily see the position of each field and differences on each field and correlation with the other fields of each sample or element he is looking for. This map, for example, was done by spraying, and the guidance system has also possibility to monitor how many hectares each size of measuring is for inside each field. So he can very easily to set and see the 3G view on the each field. Soil sampling. As I said before, soil sampling was one of the first data collection we had adopted on the farm. And it was done by farmer, or it was done by service support and service companies who is measure the field boundary and go on the field and in an even grid take soil samples from each field. It used to be done this way, and it was very useful for next management in the crop production and saving cost for example, fertilizer or different, what was the sampling done for. So, but the farmer also needs to check after every season what was done on the field. So then he can manage by the management zones the grid of sampling of each field, and just to specify the places and be more focused on where are the homogeneous place inside the field, and just sample the very useful places which can be combined with the other soil samples or other measuring on the each field or in the complete farm. In this size, in this case, we just took the samples, or the samples are done by the grid 1.44 hectares. But you can see on the pictures that the grid was created on trim lines and directions of the working of the work on the field. Precision farming technology has to be step-by-step adopt on machinery. And I'm sure it's not fully recommended that the farmers start with a complete or actually the top of technology on the tractor or machinery, but it's recommended that the farm is starting and going step by step the adoption. And as and as I explain on the first steps and previous slides, that it must be done step by step, and it must be used by farmer very easy, because the farmer has many other important things to do on the farm, and not only watching the precision farming tools and technology, but he needs to adopt these, or if he wants to adopt this technology, it is recommended to doing step by step from simple one to more advanced one and more possible and easy for work and saving cost, but much more easy for costs to buy it. So but we can start it and go step by step, one by one, at a section control, which is very important on optimal way and optimal weight for each implement. Variable rate application, which is the actually final result for all this data collection and processing on the farm. Then he can add the technology like it's auto turn for the tractor. Then he can implement repeating tasks. So it's mean that tractor is going one way automatically, and the farmer can repeat it without any touch and record it the truck and repeat it without any touch several times for each special application on the field. For example, for spraying, which is done 2 times, 3 times per each crop during a season, and we can use only the one truck. So that's farmer, or actually the people who work in the tractor, is not able to make a mistake with some. So all these technology also bring a standardization of the work on the field. So tractor is able to keep the even speed. Tractor is able to keep the even speed also about the turning on the headland with all implements with, and the tractor is able to do standardized work and application recommended for each crop differently. So this is also a very big advance that we can do a standard work during a different conditions on the field. So not every day is sunny. It could be done during a day and during a night. It could be worse condition, like it's a light rain or heavy fog or light fog, and without guidance wouldn't be possible to done, and without the good map what we had on the first slide with all these water lines and protected areas and the others what we had signed to the map of the field boundary, could be monitored and watch it and send alarm when it's the tractor is approaching to this line or electric pool and so on. So the guide and the tractor or driver can very nicely work with, and doesn't make any wrong thing, and still keep a very nice work on the field. Documentation is something what the farmer has to start from the first step of adoption of precision farming on the field. It's pretty much recommended when the farmer is keeping a digital database of field boundaries and optimal way lines, trim lines on the field, save it together and actualize it together with every year, with every crop, with every work. It can be done automatically. It can be done once or 2 times a year manually, in the database. But still, it's very important to keep the database of data very actual, because the data could go from one tractor to another, from one machine to another, and can be used only one way, the proper way, and then the saving cost and the other thing around the advance of precision farming is always done. There is no doubt that we will skip something, or we will use it a different way, or we will do something else with a different rate or something. So the driver has always very clear instruction how to do the work on the field, where to do it, and what time to do it. So the database and documentation on the field, it's a very old thing, but actually via the information technology are very, very useful and helpful to do a very precise and quick solution for the work on the field. As we know, the agriculture is very dependent on the weather and weather conditions during the season and out of the season. But still, the farmer has to react pretty quick on every conditions and every changes which are done not fluently but uneven during the year. And as we know, as the farmers know well, that the conditions the weather conditions are quite different every year, and we cannot say, okay, last year and last season was this, and I will expect it will be this again, the conditions same. No, it's not true, and even 10 years or 15 years are not the same, and year by year are very different. That's why we have a different condition of field. That's why we have a different needs every year for more fertilizer, less fertilizer, more chemicals, less chemicals. And we want to, by the tools of precision farming, really manage these needs, crop needs, to do a right way, and the save cost as a maximally possible. Farm research, as I said before, is very important for every farmer. In the first step, it doesn't have to be on each farm, but it's recommended. And it doesn't have to be some big plot or in every field. It's important if the farm research is on the right place. And actually it's scanning every work we do on the farm. And just set the study plots. It doesn't have to be big one. It could be something what we can say 2 width of, it could be a squares 2 width by spraying machine, or 1 width by spraying machine, just to make a possibility to monitor what we have done on these study plots, and easily to monitor. So it doesn't have to be somewhere on the middle of the field, as we have on some pictures on this slide, but it could be generally very closely, but the place should be enough representative for the whole farm, and it should be different for, actually it should be the same for the different crop and different application we have done on the field. And farmers should focus every year for the different crop on the same plots, just to keep the line with the crop rotation on the farm. So he can also get the good information about the crop rotation and what is important, what is not important, what is bringing more advance, what is bringing less, and so on and so on. And during he reads some special research information, and sometimes in the winter time or on the meantime, he has he's interesting to do something. It's important to compare with his work with his farm. Sometimes, and this is also my experience, that the farmer goes to look a new technology and a different farm and different location, and looks the technology works pretty well, and farmers say, okay, I have to have this technology because it brings a very good result and save me a lot in the cost and the fertilizer and the other things. But finally he get a machine to the farm and he find out that his soil are not well done by this technology, and exactly it's not what it fits to the farm. So farmer should test the technology also on his farm, and he should do also these on the farm research, some decisions, and get the final results. So this is very important for every farmer. Even sometimes the farmer may get changes between the fields, so and farms, so they can cooperate together with 2-3 farms together and just to look on the results and this farm research together with his neighbors. So I think it's very important. Something about the research and how to achieve the good result. It's also very clear. If we have some good results on the research and we are able to apply it on the farm, it's good for 1 year. It doesn't have to fit for 100% for next year, but still we have a good experience that we did this and that, or farmer did some special application or special steps, special entrance and more entrance and more applications or less, he could save or he can more invest to get the optimal quality of the yield, but still he can be satisfied with the quality and amount of the yield he wants to sell in the future. So if we get the first picture from the left, and the farmer has these snakes up and down every year, or just during increasing some rates or whatever, there is usually no conclusion, because he cannot say, I increased the fertilizer or I increased the entrance from 1 to twice, and there is no once it was better, one it was worse. So there is no conclusion, and we should do something completely different. If we have, for example, the second picture from the left, the possibility that the yield is going down, and all these applications and what the farmer is doing, it's not helpful too much. He is probably using a too high rates or too much everything over, and he generally over applying the situation, actually the crop production. If we take the third picture on the farm yield and we find the optimum, so we find positions when we go up with the increasing, and when we go down when we over apply. And this is very important thing, and we probably find the optimum of our research rates or entrance and so on. And the last, not the least, but could be a position when we go up, always with every entrance, with every increasing the rate and so on, and we are still achieving a higher yield. So we're still under applying the rate what we can do. So this is a very simple thing and positions what the farmer can achieve, and what the farmer should take in mind what can happen on each field with a particular crop on the farm. Another picture about the farm research is that we have farms with the fields, as we see on the right picture. Then we can, the farmer during 5-10 years, maybe 15 years, can achieve a pretty high result and saving cost and the other things. And then he need to increase the knowledge to pushing all things more forward. So generally, the farms who started, let's say 20 years ago, and today they have a very nice results from variable rate application and these optimal ways and optimal trim lines and sample collections, soil sample collections, or crop samples collections, or monitoring the weather, or others. It's always good to go step by step, and they can achieve a higher and higher results. It's good, but what is important to just don't stop and just continue with the news and get a better knowledge inside the technology or planting or crop production. It's very important to don't stop and just continue a nice work and nice results in the farm. So this is probably all for today, when I would like to explain to you how to start with the precision farming and what are the recommended first steps, what the farmer should do it on the farm when he decided to start with the precision farming. Today we have a nice experience, so we can summarize that what is the best to start, what is the second, what he should continue, and how to apply whole system and circle around. So I would like to say that all pictures and calculation results are created by ACO and created by my colleagues with many surgeries and researches on the farms, and ACO as a member of AgriHub Czechoslovakia. So thank you very much to being a part of the AgriHub Inspire Hackathon, and I can put the place for the questions or some ads or comments or whatever. Thank you very much.
Thank you very much, Pavel, as well from my side for your very interesting, clear, straightforward, clear, well-structured presentation. And you can stop the sharing your screen right now, I think so. And now it's the right time for the audience to put the questions into the chat, or you can unmute your microphone and speak up if you want to. So please, if there is anything you can ask about, it's the right time.
Okay, if there is no other person, I will try to be a little provocative, Pavel. At first, I would like to thank you for your very inspiring presentation. Yes, it was very nice. I can say, because we know each other for a long time, that you can be called something like grandfather of the Czech precision farming, because you started with this very long time, and you change different position. Yes, advisor, researcher, agronom in the farm. Now you are in the machinery. But I will be now a little provocative. Yes. You can remember that in the 90s, usually when it was discussed why precision farming or agriculture is not accepted by farmers, was answer: farmers are too old and we have to wait on a new generation. But what is interesting, that I heard this sentence minimally twice or three times last year on different meetings, but we can say that one generation changed, yes, and we are till now answering in the same way. Where is the mistake? Yes, what we have to do to attract farmers?
Yes, from my experience, it's I had a chance to see how the precision farming was developed during these 25 years. And exactly what we said in 90s. It was that the farmers are not very friendly with IT technology, and something to add to his tractor cap, it's quite difficult because he doesn't want to use it. So it used to be, and I remember the time when the farmer didn't want to start with the guidance because it was something what he doesn't need it. He just spent the money with. And today, if I can say, the farmer who start to use it, the guidance, almost immediately, if the guidance has some trouble or doing something wrong, the farmer say the tractor doesn't work. Even if the tractor is running as usually as before, as everything, but the not guidance is accurate enough because the satellite or correction signals is not receiving well, or some other small troubles, the farmer doesn't want to work without. So this is my first experience. But let's say and answer the question. Today, and the precision farming, it's not something what is very easy to adopt on the farm. And people must be really funds to the new technology, and must be pushed by some saving of money. And we could see it the last half a year in Czech Republic market or any Central European market, that the price of fertilizer was straight up 300% or whatever, 200%, 300%. And the time I started with the precision farming, we spoke about the saving maybe 20, maybe 15 euro per hectare of the fertilizer. And today we can easily spoke about 100 euro per hectare for fertilizer only. But the precision farming brings with the guidance and the sound technology much more. And I think it's about the people who wants to change something what is from the history on the top level. Because if we say that the farmer works with a 6 meter width or 12 meter width or 36 meter width, who was sitting in the tractor and trying to turning or doing something on the field with a small crop or high crop, today he knows that the guy in the cap is lost if he doesn't have anything what he tell him the tractor must go this way or that way. So this is very important. And what is the one of the most let's say things what doesn't let the precision farming adoption on the farms is the technology, all technology which is running well on the farm, and farmers doesn't want to invest the money for the technology. So in one side, he doesn't want to, actually the farmers doesn't want to, not everyone, but many farmers still doesn't want to go and learn these technology, IT technology, and let me say precision farming technology and smart farming technology or IT. But he always say, my tractor is still good and running well. But if we compare tractor which is running with the guidance on, let's say, on the highest centimeter accuracy, and tractor which is not running with the guidance, there we can speak just basically about the 5% of saving. So everybody can easily calculate. And this is my third thing, what I would like to say. The calculation of saving costs wasn't very common. Everybody spoke about the calculation and saving cost, but today exist easy tools when the farmer can easily calculate by himself and calculate on his farm what he can save it exactly and what he can't. So I think this is the most three results, what we can say why the adoption of precision farming in every market isn't so hurry up. I don't know, not hurry up, but not applied enough.
Okay, I think that this automatic guidance of machinery is probably till now the most often accepted by farmers minimally in the countries where are the biggest farm. Yes, so this technology is successful. But as you mentioned, but as we know, the precision agriculture is very wide. Yes, it is a variable rate application for nutrients, chemicals. Now is discussed and it is supported by machinery, variable seeding. What do you think that probably can be, or variable irrigation, that could be second candidate for broader adoption?
If we take generally step by step, and what is most important, and what is the second and third, actually all three things are very important. If you do a good drilling, right way and right position, and make a variable rate, it's very important. But if you do a wrong fertilizing, or if you do a wrong chemical protections, it's making more or less lost than the saving. So all four parts, let's say, soil preparation, seeding, drilling, protection, crop, chemical protection, and fertilizer, even, let's say, harvest, which is also very important. It must be on the same level, but technology, what supported these first five main steps, applications on the field, are developed on different ways and different levels. I think the most applying is the variable rate of the fertilizer, then the chemicals, and then maybe soil cultivation and drilling. And actually, the drilling is a very nice to be adopted, and variable rate to be adopted, but it's still the technology is not so shared enough and well known between the farmers generally. Not, of course, a good farmers and the top of the farmers who adopt the technology are known already several years, but I would say the fertilizer and soil cultivation preparation for drilling, then chemical protection, and unfortunately the latest will be the drilling, because it still takes some more better adoption of technology and maybe better test. But everything is a depend how much is it supported by the data and the specialists. So some country can have a good specialist for drilling, and they can go forward much faster than the others. So it's depend on the people skill and farmer skill and possibility to get this technology on the farm. So it's very hard to say what will be go. If we say what has a more tradition, we have to say that the variable rate of fertilizer, and then chemical protection, then drilling, and then maybe together with the fertilizing yield monitoring. But this is about the data collection. This is not something what brings exactly. It's very important, yield harvesting, but it's something what is coming with.
Okay, one more thing, yes, we discussed the technology, ICT, machinery technology, we discussed the farmers, but I think that there is one more pillar, and it is research and education. What do you think about this? Because AgriHub sees that SK is partly a research project, and how you see the link between researcher and practitioners. And my opinion that sometimes research is very often focused very narrow. And I think that from my point of view is missing some wide research covering all aspects of precision farming. Yes, because farmer needs to understand all. So what do you think about the role of research and of course also education, because education is transferring these experiences from research to practice?
We have to say what kind of research we are focused on. Generally, for research for precision farming, it's still very various, and it's important which way to go and what brings to farmers. As you said, it's much more important is to bring researchers, universities, people, and farmers together, and bring these kind of sessions more often to the market and just talk to people and bring the knowledge from researchers to university to farmer. And it means that the students must be the main potential of the new development and the adoption of precision farming, and the students as the farmers and the students as the advisors and specialists. So these people are most important for the next development of all systems. And of course, on the other side, it's always depend who support the research. And this is also on the way, which way the research is going. So as we know, the last 10 years was a very big development of these guidance and accuracy signals, corrections, and the other thing. And it brings the very nice saving and doing the right work. But still we have a big lack of, for example, as you mentioned, that the drilling or chemical protections or fertilizing. So this is something what we should move forward a little bit, push it forward a little bit. So this is
maybe one addition, since you mentioned that researchers has to transfer knowledge to the farmers. What do you see opposite? Yes, that sometimes probably is for me missing the inputs of the farmers to the researchers. Yes, to really define farmers' need.
Yeah, it's from my experience, it's done a little bit by situation that the farmer is running the farm, and it doesn't mean that the farmer is not only on the field and the farmer is not only watching the news from the precision farming. And sometimes the harvest or any kind of application on the field is on the big press, because they hurry up because the weather is coming wrong, or they hurry up because the crop should be on the soil already. Actually, the seeds must be in the soil already in the time. And the farmer generally hurry up with all these terms and all these other things. And furthermore, usually in our areas, the farmer always has to calculate the money. So the business is in one place, first place on the press on the farmer. So farmer needs to produce and sell it, and the farmer is just continuously in the big press with the money and with what happened with the crop on the field and so on. So just focus on technology of precision farming is quite how to say, it's quite difficult. So in the eyes of the farmer. So sometimes we cannot say, we want to communicate with the farmer. I have also good communication with the farmers, with the pilot farms, what we have for testing and Czech Republic. But I see, if I want to call to farmer, I have to always ask, do you have a time to talk to me? Because the farmer has many other troubles and he needs to focus also on these. So sometimes can happen that the farmer not responding what a researcher needs in the time, and then it's maybe it's stop it for some time because we work with the seasons. So it's quite difficult. Yeah.
Thank you. I would like left the floor for others if others has some comments or questions.
Yeah, thank you guys very much for the interesting discussion of yours. I think it was very inspiring as well as the presentation itself. So as I see, we don't have any question in the chat and nobody is raising his or her hand. So let me wrap up this webinar with the information that all the contact emails, either for Pavel Gnip, the presenter of today's webinar, or the contact email of a person if you would like to have an e-certificate on precision farmer training. All of this information is available in the chat as well. So from my side, thank you very much for joining us. And once again, the recording will be available in several days. So you can see the recording of this webinar later as well. So thank you once again for the last time and have a nice day. Thank you, Pavel, for having this very interesting presentation.
Thank you very much. Thank you very much for all. Thank you for listening.